Let's take a look at an exercise on independent variables. In this exercise, we have two variables, x and y. They are both discrete and they are independent. And the fact that they are independent will be very important here. X takes on the values 1 and 2, and y takes on values 1, 2, and 3. What you see here on the screen in green is what we know about those variables, and what we want to obtain is the probability that x is 2 and y equals 3. So what do we know? Well, first of all, we know that the probability that y is equal to 1 is 1 over 6. The probability that y is larger than x is 1 over 2. And the probability that x is 1 and y is 2 is also 1 over 6. So that is what we know, and we want to find out what is the probability that x equals 2 and y equals 3. Let's use this information to complete this little diagram. So in this diagram, I want to write down all the different probabilities, the probabilities that x is 1 and y is 1, the probability that x is 1 and y is 2, and so on. So actually this diagram represents the joint probability mass function of x and y. So far, well, there's only one thing we know. We know what the probability is that x is equal to 1 and y is equal to 2. We already know that that is 1 over 6. We will also need the marginal probability mass functions of x and y. In this diagram, I'm going to put them at the bottom and on the right. So here on the bottom, we will put the marginal probability mass function of y, and here on the right, the marginal probability mass function of x. So far, there's only one value that we know. We know that the probability that y is equal to 1 is 1 over 6. Let's write that down over here. So here we will write the probability that y is equal to 2. Here the probability that y is equal to 3. This position will contain the value, the probability that x is equal to 1. And here we will write the probability that x is equal to 2. Okay, let's see what else do we know that we can use to complete this diagram. So far, we haven't used this piece of information. The probability that y is larger than x is equal to 1 over 2. Well, when is that the case? Let's say that x is equal to 1. Then y should be equal to either 2 or 3. If x is equal to 2, then y should be 3. So that means that this red area over here in the diagram has a probability of 1 over 2. We also know that the probability that y is equal to 1 has a probability of 1 over 6. So this area over here has a probability of 1 over 6. Well, that actually allows us to compute this value over here, the probability that y is equal to 2 and x is equal to 2. Because we know that the red area, the larger area over here, has a probability of 1 over 2, and this a probability of 1 over 6. If we add those two, then we get 1 over 2 plus 1 over 6, and so that's 3 over 6 plus 1 over 6 is 4 over 6, or 2 over 3. Well, since the total probability should be equal to 1, we know that this value over here should be 1 over 3. That's since the probability of the red area is 2 over 3. Now we're close to solving this entire puzzle. Because with the information that we have right now, we know that the probability that y is equal to 2 is equal to 1 over 6 plus 1 over 3. So that's 1 over 6 plus 2 over 6. So that's 3 over 6. Now we also know that y only takes on the values 1, 2, and 3. So if the probability that y is equal to 1 is 1 over 6, the probability that y is equal to 2 is 3 over 6, then the remaining probability should be 2 over 6. And because this total probability, of course, also has to be equal to 1. Now we can use the fact that x and y are independent. Because being independent for discrete variables like these means that the probability that x is equal to k and y is equal to n is in fact equal to the probability that x is equal to k times the probability that y is equal to n. We can use that here. For example, this probability, the probability that x is equal to 1 and y is equal to 2, should be equal to 3 over 6 times this probability over here. Well, if 3 over 6 times this other probability should be 1 over 6, then of course that means that here we have to have the probability 1 over 3. Now x only takes on the values 1 and 2, so this other probability, the one over here, this marginal probability mass function, takes on the value 2 over 3. So now we have found both marginal probability mass functions. And since x and y are independent, we can use this blue formula over here to complete this diagram. Now remember, we were looking for this particular value. The probability that x is 2 and y is 3. And so this value over here. Well, let's use the fact that x and y are independent. So that means that the probability that x is equal to 2 and y is equal to 3 is equal to the probability that x is equal to 2, well, that's 2 over 3, times the probability that y is equal to 3, and that's 2 over 6. So the result that we get is 4 over 18, or 2 over 9.